Okay, last one. Whoops, you don't need to see this. Last one looks like a nova. So, calculation quiz 4, looking for the link into a nova. Given the responses and treatments of blah 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 blah, test whether there is a difference among the means of the groups. So according to this, it looks like it wants raw data. So that's why we have a link here for raw data in capitals, because this looks like it's just going to give me a bunch of information or sets of data. Let's go over into that calculator and see what we have. Whoa! Okay, so it looked like there was what? 3 groups of data here. So let's come in here and say there's 3 groups of data. Assume they're all independent of each other. And we're just going to enter some information into this. So this would be like ABC. So about 3 pieces of information in each one. So something like 1, 2, 3, and then maybe 5, 4, 5, 3, 4, and then maybe 2, 5, 3. Okay, what this ANOVA test does is it kind of tests all of the means, and it tries to see if there's a difference amongst all of them. So when you calculate from here, you get a whole bunch of data, a whole bunch of information. But the relevant things to us here are going to be an F-score and a p-value associated with that F-score. So we're going to get sets of data, we're going to insert sets of data in here, and it's going to test to see if there's a difference among the averages. Notice the average here is around 2, and the average here is 4, and then 5, 6, 7, 8, 9, 10. That's about a 3.3. So you get 4, a 3.3, which are close to each other, and then a 2 that is a little bit lower. So this checks to see if the averages are significantly different. So for those of you who have huge groups or lots of different information from different people, you might want to see if there's a difference of the means between the different groups. And that's what this really calculates out for us with the F-score and the p-value. Okay, so let's make ourselves up a problem. I use fertilizer A, fertilizer B, and fertilizer C to grow some tomatoes. The size of the tomatoes, the weight of the tomatoes, that received A were, let's put some numbers here. Let's say that the weights were something like 35, whatever is grams or something, and then 23 grams, and then 43 grams, and then 54 grams, and maybe 32 grams. For B, I had, and let's say that we actually had a different number here. I don't think, and it doesn't matter. I know it doesn't matter if we have these, if it has different numbers. So instead of having 5 of them, let's just have 3 of them here. 12, 14, and 13. And then for C, maybe in real science classes, sometimes this is your control group or something that received no fertilizer. Maybe they had sizes that were about, let's say, 23, 32, 43, 39, 32, 13, let's say there's a light guy in there, and then 45 and 23. So notice that we have, it looks to me, just from the raw data, that the averages here and the averages here are somewhat close to each other. They all look like they're in the 20s or 30s, and I can calculate those. But B, actually, it looks like that's a really terrible fertilizer in one sense, because the weights were actually much smaller than we would expect. Or maybe if it was the amount of sodium, this would be a good thing, right? Not sodium in tomatoes, I guess. But you can test different sizes of things between groups and test to see if one of the groups is different from the other groups. So the hypotheses here would be something along the lines of, whoopsies, I don't want this. 1 of E, H sub 0 is something along the lines of, there is no difference among the groups. And your alternative hypothesis is H sub A. There is a difference among the groups. So specifically in the context of these tomatoes here, it's like saying the fertilizers do affect the growth, and this one's saying that, no difference is the null hypothesis, and the alternative that we're trying to prove is there is an influence here. There's something that we need to go in and look and see where those differences are coming from. The statistic in this case is called an F statistic. And we're going to find out what that equals, and it's going to give us a p-value, and once we get that p-value, we're going to be able to make a conclusion based on this data. So let's move ourselves over to this crazy ANOVA. Notice I already put the number of samples, so I'm already safe on that. There's 3 samples, fertilizer A, B, and C. Let's assume they're independent from each other because they're given different fertilizers. And this time in the data entry, it looks for that first group like it was 35, 23, 43, 54, 32. In the second sample, I'm getting at 12, 14, 13. And in that last sample, I'm seeing a 23, 32, 43, 39, 32, 13, 45, 23. So they're even different sizes, but each one has an average. There's an average here, and an average here, and an average here. And we're trying to see if there's a difference in the averages. So let's go calculate that junk. Boom! F score, 5.32. F statistic, 5.32. P-value, is that significant enough for us? Let's see, 0.0205. Yes, ma'am, that's less than 0.05. So we get a conclusion here, we get to reject our null. We have evidence that there is a difference among the groups. So that would be the conclusion from this hypothesis test. Okay.